Chapter 5, Section 4, Binarization. In this section, we will focus on when and why binarization is useful in data analytics, how binarization simplifies categorical and numerical data for better interpretation, how to implement binarization by Python. Binarization is the process of converting numerical or categorical data into binary, 0 or 1, based on a threshold. Binarization reduces complexity while preserving key information, making it easier to interpret data. Binarization is commonly applied in the following cases. The first is converting continuous variables into categories. Some numerical features are more meaningful when categorized. For example, age can be split into young versus senior for workforce diversity analysis. The second is encoding categorical variables into binary indicators. If a categorical variable has more than two categories, we can create binary indicators for specific groups. For example, if a dataset contains job roles, HR, ITs, sales, engineering, we can create a binary column for IT employees, 1 if IT, 0 otherwise. This transformation helps in simplifying models and making them more interpretable. As an example, let's consider an employee dataset that records employees' tenure. Instead of using tenure as a continuous variable, we may define a short-term employee as an employee whose tenure is less than or equal to 5 years, and a long-term employee as an employee whose tenure is greater than 5 years. And let's encode tenure as a binary variable, with short-term employees as 0 and a long-term employee as 1. After binarization, the dataset will be revised in this way. Now, let's implement binarization by Python. First, import libraries. Import pandas as Ph.D. Pandas is used for working with tabular data. Import NumPy as NP. NumPy provides numerical operations, including conditional operations. And from sklearn preprocessing, import binarizer, which is used to apply binarization. The following code applies binarization to the tenure column in a data frame named df. In this case, if tenure is longer than 5 years, the value will be 1. If the tenure is 5 years or less, the value will be 0. We can use NumPy_where, which is a useful function for applying conditional transformations efficiently. NumPy_where has 3 arguments. The first is a Boolean condition. The second is the value returned if the condition is true. And the third is the value returned if the condition is false. Here, the condition is tenure is longer than 5, and if it is true, 1 will be returned. And if it is false, 0 will be returned. The resulting binary values are stored in a new column named Tenure Binary Manual in the data frame. As we can see, the resulting data frame has the new column named Tenure Binary Manual, which contains 1 if tenure is longer than 5, and otherwise 0. As another method, we can use binarizer for binarization. First, initialize the binarizer. Set the threshold value to 5 to ensure that if the value is smaller than or equal to 5, it will be 0. and the value is larger than 5, it will be 1. Next, using a fit transform, apply binarization and create a new column named tenure binary. In fit transform, we need to pass the tenure column as a two-dimensional data frame. Binarizer requires a two-dimensional input, that is, a data frame, instead of a one-dimensional series. So here, we need to pass the column tenure with double square brackets. The newly created column tenure binary has the same data created by NumPy-where. As we can see, the same binarization result can be obtained using either NumPy-where or scikit-learn binarizer. As an advantage of using scikit-learn binarizer is that Binarizer enables us to apply the same threshold-based transformation to multiple columns at once. This is more efficient than manually writing NP-where for each feature. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.